Now we're going to talk about using deductive reasoning. So one of the things that we need to look at is what can you assume is true? Because deductive reasoning is based on things that are true. So we can assume that definitions, like definition of a square, axioms, postulates like 2 points are always collinear, those things, those properties are always true. Now the other thing, when you're doing a specific argument, you will have some things that are called given. Given are true for that problem. They don't have to be true forever, but they are true for that problem. So if it says given, that part is true. When looking at diagrams, it's important to know what you can also assume is true. So collinear points, if I have A, B, and C on a line, then they are on the same line. I'm not trying to trick you and say, oh, B is really close to the line, but not on the line. Also, betweenness of points. If I go A and then B and then C, you can assume that B is somewhere between A and C. You can't assume it's halfway, but you know it's somewhere between. Coplanar points, so if you see 3 points and they look like they're on the same plane, then they are coplanar. Most of the time we'll be dealing with coplanar points. Straight angles, so angles that make 180 degrees, so there's a straight line on one side and then the angles. You can assume that those angles are going to add to 180 degrees. Straight lines, if they look straight, they are straight. You don't assume that the copier didn't mess them up, that they're straight. Adjacent angles. If two angles are right next to each other, meaning they share a ray, then they are adjacent angles. Linear pairs of angles, that's like straight angles. Linear pairs are where they add up to 180 and they are adjacent. Vertical angles are when you have two lines crossing and then the two angles opposite of each other, either the top and bottom or left and right. Those are vertical angles and you can assume that they are congruent. Things that you cannot assume. Just because it looks like B is halfway between A and C on a segment does not mean that it's actually halfway between. You can't even assume that the segment that looks bigger is bigger. You have to show mathematically, give me a value, why one side is bigger than the other. The same is true for angles. Just because it looks like a 45-degree angle doesn't make it a 45-degree angle. Segments that are congruent, you cannot assume that segments are congruent unless they have the little congruent marks. The same is true for angles. Also, one of the big things that happens is people say, oh, that looks like a 90-degree angle. That must be 90 degrees. No, you cannot assume that unless there's that little square in the angle that says, yes, that's a 90-degree angle. So the law of detachment is one of the most basic tools in deductive reasoning. What is the law of detachment? Well, it says if the statement, if P then Q is true, then that means if P is true, then Q is true. We use the conditional statement. So what that means is if the statement P is inside of Q, that means if I'm standing in P, and hold on, let me come back up to it. Sorry, I lost my pointer. If I'm standing in P, then that means, because P is entirely contained by Q, then I am also in Q. Now, if I'm standing in Q, that's a different matter. But if I'm standing in P, and this is a true statement, you can assume that I am in Q. So how do we use it? It helps to identify which part is the hypothesis. So see how we have the given here. I told you about that. These two are assumed to be true, all right? Automatically true. So it is Sunday morning. That's the hypothesis. Then Mrs. Overman is at a nursing home. That's the conclusion, the Q. All right. So if I do a Venn diagram, so I'll do P, right? And we'll say Sunday. And then nursing home is Q part. So I'll do NH for nursing home. So if it is Sunday, then morning, should say morning, then I am at the nursing home. All right. Well, the other thing they tell you that is true, they say I am volunteering at the nursing home. Well, that means I'm in Q. All right. I'm in this whole big area right here. Does that mean it has to be Sunday morning? No, it could actually be a different morning. And in fact, I do volunteer sometimes on Saturday mornings. So This is not a valid argument, not valid. Because what we're saying is I'm giving you Q, I'm not giving you P. So you can't assume because of Q, then P. Let's take a look at another example. So again, given, so these are assumed to be true, all right? If all sides of a quadrilateral are congruent, all right? So that's the P. Then the polygon is a rhombus. This is the Q part, all right? So if I draw my Venn diagram again, all right? If all sides of a quadrilateral are congruent, then the polygon is a rhombus. So let's take a look. All sides of a quadrilateral A, B, C, D are congruent. Which part of the argument was that? That's P. That means I'm in here. Well, if I'm standing in P, then I'm definitely in Q. So this is a valid argument if I want to prove Q. And what does it say? Quadrilateral ABCD is a rhombus. This is Q. So this is a valid argument. Now our next law is actually quite interesting. It's called the law of syllogism or the law of transitive reasoning. So if P then Q and if Q then R are true statements, so if we accept those as true, and they could be shown as a given like in the other examples, then you can assume if P then R is a true statement. So what does that mean? Well, P then Q means that P has to be completely inside of Q. Q then R means Q has to be inside of R. Well, doesn't that mean that P then has to be inside of R? It does. So we can assume, we can skip straight from P to R. And I have a cute little commercial to show you that shows this sort of law of syllogism. Now, the trick is they have to be true statements. Now, the commercial is not 100% true, but it shows you the chain of events to get from P to Q, Q to R, and in this commercial, R to S, S to T, etc.
When you wait forever for the cable guy, you get bored. When you get bored, you start staring out windows. When you start staring out windows, you see things you shouldn't see. When you see things you shouldn't see, you need to vanish. When you need to vanish, you fake your own death. When you fake your own death, you dye your eyebrows. And when you dye your eyebrows, you attend your own funeral as a guy named Phil Shifley. Don't attend your own funeral as a guy named Phil Shifley. Get rid of cable.
All right, let's take a look at example 5. If Mary studies for her test, she will make an A. So these are given. We can assume these are true. Okay, if Mary studies for her test, she will make an A. So this part, if, that's P. She will make an A. All right, that's Q. Notice how they left off the then. That's okay. Then, if Mary makes an A, hey, we said that already. That's our Q from before. Then her mother will buy her a new outfit. Her mother will buy her a new outfit. That's R. Okay? So we find out it's true that Mary did study for her test. So that means I can assume then that she'll make an A and that her mother will buy her a new outfit. So the conjecture is R. Mary's mother bought her a new outfit. Well, since I know that P is true, let me go ahead and draw my Venn diagram. Q and R, and pretend that P is completely inside the Q. Sorry about that. So I'm standing in P. That means I'm definitely in R. This is a valid argument. Valid. All right. Example 6. So now we have if all sides of a triangle are congruent. So let's identify our hypothesis. That's P. Then it is equilateral. Okay, so the triangle's equilateral. That's Q for this part. If a triangle's equilateral, so this is kind of like our crazy commercial, then all angles are acute. All right, that's R. And then they tell me that this part is true. All angles of a triangle are acute. They told me R. R is true. All right. So what does that mean? Let me draw my Venn diagram again. P is inside of Q. Let's see if I can do a better job there. And here's R. What did they tell me? They told me I'm standing in R. Well, standing in R doesn't mean that P or Q are true. All right. So I cannot assume P or Q. I know R is true. Well, which one did they ask me for? The triangle is equilateral. They asked me for Q. I can't assume it. This is not valid. Oops, helps if you spell valid right. Final example, example 7. Draw a conclusion from the given information. If lines A, B, and C, D are skew, all right, so that's our P, then they are non-coplanar. Non-coplanar, that's Q, all right. If they are non-coplanar, that's still Q, then the points A, B, C, and D are non-coplanar, all right. So that's R. So let me draw this. P, Q, and R. It says lines A, B, and CD are skew. So I'm actually in here. That means if I'm in P, then Q is true. They are non-coplanar. A, B, and CD are non-coplanar. And CD are non-coplanar. So I can assume Q. And, if I can write that, and I can also assume R, non-coplanar. All right. And they are, let's see, what was R? R is A, B, C, D. And I'll say R non-coplanar. Those little dots mean ditto. So I can actually assume Q and R because I know P is true. So for now for your reflect. How can you tell the difference between inductive and deductive reasoning? I've sometimes seen it with a picture, like inductive is general observations to specific rules, and deductive is specific rules to general. So they'll sometimes do that. So maybe that'll give you some ideas. The big thing to know with inductive is that has an eye, as in an eyeball. It is based on observation and specific cases. Hopefully that helps. Deductive is based on rules and laws. Maybe you've seen the blind lady with the rules and laws. So it's always true. Inductive can be proven false. Deductive, done properly, is always true.